again, thank you all for coming in today. These sessions, I created these sessions just to help, people everywhere just to kind of see how you can architect and design a system, no matter how complex this system is. Just a little bit about myself, who am I and why I'm talking to you about this. My name is Hassan Habib. I'm a senior software engineer. I've been in the tech industry for 21 years now, and I built over 39 enterprise level systems. And you start building things and working with people from different places with different backgrounds, patterns start to emerge, right? And I decided, well, that knowledge needs to go somewhere. So I wrote a book and I called it, the standard, the engineering standard, which basically helps engineering teams kind of know where, at least where to start when they're thinking about solving a problem, right? How to begin, how do I break down an existing system or start a new system from scratch? What are the principles and characteristics and the information that I need to go find? And whether you are a program manager or an engineer, believe me, you're going to run into this problem where you're saying, okay, there's this new requirement. Where do I start, right? Where do I begin? So I'm gonna, pull out here, draw IO, and I'm gonna start showing you guys some drawings, some nice. We're gonna build some, shapes together and patterns, and we're gonna hopefully ask questions. The reason why I broke these groups, we have about 21 groups. The people that signed up to this series is about 1,400 people. So I intentionally broke it down into smaller groups like these, 50, 50, 50, knowing that probably 20 is going to show up and the other 20 is just going to watch the recording. I made it intentionally this way so you can ask questions. So please engage, ask questions. If anything is not clear, something that is not clear to you, please feel free at any point in time, say, Hassan, wait a second, I don't understand what this means. All right. So here's the deal. I'm going to walk you through the process of designing, an enterprise complex system, right? So you're starting to get some requirement, right? Let's just put a requirement out there and say, I want to here. So here's your requirement. And you're basically saying, I want to here. I want to design a schooling system that allows students to register on that system and sign up to courses and view their schedules, right? You get a requirement like this, right? Some raw requirement, bare bone, there's no magic in there, right? And you're thinking to yourself, what can I do with a requirement like this? How can I take this, as an engineer or a program manager or someone who wants to build systems? And how can I take this and make it a system, make a system out of it? I'm going to start putting some colors here just so you guys understand. First thing you would want to do is to kind of find out the nouns in your requirement, right? So I see, schooling system. I see, let's just put here some colors on these. Here's this guy, schooling system. I see a system in here. Let's put that in there. I see a allow students. I see students. Here's my nouns. I see register, I see system again. Here's a system again, like here. I don't know why the coloring is off, but here we are. This. To sign up to courses, well, there's courses right here. To view their schedules. Okay, so you found out, a bunch of nouns in your system. You want to design a school system that allows students to register on that system and sign up for courses to view their schedules. If you just look at these nouns, these things, determine what are the models and the entities that govern your system, right? So as soon as you look at something like this, is okay, I know where are the entities, and these entities can be people, can be, hardware, it can be devices, it can be things, it can be anything, right? So I'm going to put these out here. I'm going to say, okay, I see a school system. I see a student in here. I see a courses. And I see schedules, just like this. What I just did here is just trying to model the problem. I'm trying to extract the components in my system that actually, play a role into determining the skeleton of that system. But that's not enough. I want to connect between, I want to create the connection between these models, right? So this is the part that I call simulation. So that basically means the students are going to be using the schooling system. The students are going to be able to see, I'm creating user stories as I go like this. The students are signing up to courses, and the students are basically checking out their schedules, just like this. See how I created from a raw requirement? You know, if you look at the verbs in your system, you will notice, well, you know, this is a view schedule like this, view like this, and you have sign up in here, right? And maybe, I don't know, you have, you know, maybe, you know, log in here. Okay. So what I just did there is what I call modeling and simulation, purposing modeling and simulation. I created models and I simulated the interactions between these models. Now, all of a sudden, your raw requirement all of a sudden turned into a material that can be turned into features and user stories and tasks and, you know, whatever you want it to be. If you look at the verbs in here, this is, I'm gonna color the verbs in a different color here, so just so you see how I'm looking at this. There's register, there's sign up like this, and there is a view their schedules. If you look at any raw requirement that you have out there and you find the nouns and you find the verbs, immediately you can see, you know, how you can extract a bunch of models and the simulations, the interactions between these models. And all of a sudden now you are easily able to go and say, well, now I know what the feature is. This is my purple ticket. I can now create a bunch of blue tickets that can resemble how I break that system apart into user stories. We'll take 1 minute break here and just ask if anyone has any questions about any of that. What do you guys think? Yeah, total nonsense. Okay, got it. All right, let's move on. Maybe I can surprise you with the next one, right? So if you determine your system like this and you're trying to build this system as a piece of software, there are three things that you have to be really aware of, right? The first thing is, you know, you need to determine in your system three big important pieces that will govern how you design and implement that system. So let's start this way. There are pieces of your system that I call exposure components, right? Think APIs, UIs, you know, SDKs, libraries, you know, DLLs, things that you create so people can have access to your system. And then in the middle here, there is operational, right? Operational components. These are the ones that basically do the core business logic. This is the stuff that actually takes the data, determines where the data is going, and basically, you know, runs the validation, runs your business rules, and all the kind of details that you need to do to design a system. The last one here is the integration components. Integration components, and I'm going to give you some examples for these real quick. So this is just from day one, you're getting a requirement. You need to be able to determine these things, what your models are, how they interact with each other. And then all of a sudden, you also need to determine how you're going to put these models into a system that can support this. For instance, let me go and take this piece, just this tiny piece in here. If I take this tiny requirement in here and I go and say, okay, based on this tiny requirement, what is my exposure components? It's something as simple as going and saying, well, your exposure component here will be a login page, a login or registration page, right? You're just collecting the little pieces that kind of determine how your system is going to look like. And then in here, your operational components, maybe you want to be able to do, you know, authorization, authentication, and you want to basically run some validation and registration in here. That's some business logic. And then the last thing is your dependencies. Maybe you rely on AAD, maybe you rely on some other authority. I'll just put AAD in here. So you're basically going and saying, I'm using AAD to be able to register my students into the system, and I'm going to rely on this, you know, provider to allow me to do that kind of work. All right. So what that basically means is that, okay, I identified the components that would allow me to get that feature that I extracted from this very raw requirements into something that engineers could look at and be like, oh yeah, we can create user stories out of this. We can actually design a system out of this. So let's take this a little bit further. In any distributed system, you can go and say, I want a UI component. I want a portal, the UI web component or mobile component, and I want an API like this, and I want to be able to have basically an Azure dependency or an Azure resource. Make that communication. If you break your system and requirements this way, you can deliver features with the speed of light because there's clarity. You know now where you want to start and where you want to end, and you want to basically, you know exactly what components you want to target in order for you to deliver a particular feature, right? And then you can create the tasks under each one of these and basically go and say, this is how I want to basically design that system. Any questions about this part? Anything at all? I'll take 30 seconds this time. All right. All right. Okay, so if you can easily determine what your exposure components are and what your operational components are, what your integration or dependencies are, now you can basically design a system like an architecture that can support your needs because eventually at some point in time these components are going to start to kind of be reutilized, right? Like we talked about a web UI component or a mobile application. So if I'm going and architecting my system, I can now go and say, well, I need an API endpoint that can support my system. I need some database to tell me, what students I have on my system, and I also need to be able to communicate with AAD to make sure that authentication authorization work is going on. And I need a UI component, maybe a web application that will allow me to basically connect to that API and basically run my processes. So again, out of the simple raw requirements, we started breaking it to the lowest level where you can actually get architecture components, setting in here and basically kind of managing these processes as we go. Let's dive a little bit deeper into that. Well, I know how these UI components and backend components are supposed to look like, but what's inside that API and what's inside that UI and what's inside the database and all that kind of stuff, right? So when we try to design systems like these, we try to make sure that your system is pluggable. It's able to, integrate and work with multiple systems, right? If you decide one day that you want to switch from SQL to Cosmos, if you want to switch from, I don't know, Azure Blobs to Oracle database, it should be very simple and easy for you to just go and actually make that switch without having to do too much work in terms of engineering effort to make that switch. Especially if you're planning to productize an internal project or to continue to maintain a product that's out there. So let's look a little bit deeper into this guy. I'm gonna kind of zoom in and show you what this guy would look like. Every time, again, back to this rule, you have integration and operational and exposure components, exactly the same thing at your API level. I want to go here and say, well, I need something called a storage broker, something that goes and talks to the database without impacting my business logic. I don't want my internal core software to know that I'm using SQL or Cosmos. If your business logic knows that you're using a particular technology, then you're already kind of allowed, an external component to leak into your business logic and dictate certain things based on the, capability of that particular technology. But I also want some API, an API broker to basically go and communicate with this Azure authority, like AD, some authority that, basically allows me to kind of check and see the tokens and all that kind of good stuff. And if you build on top of that, then I need to kind of create my business logic layer, something that goes in here and says, well, if you're going to add a student in here, you need some service in here, and it's just a simple class, a C# class or Java class, whatever class you were trying to build. And what this service does is that it just allows you to run validations on simple primitive operations. If you're adding a student into your database, you want to run kind of 3 different levels of validations. You want to make sure that your student information are structurally correct. That basically means the student name cannot be empty, null, or white space. You know, if the date of birth it needs to be also logically correct. Like their date of birth cannot be, 500 years ago. That's logically incorrect, right? You also want to be able to have external validations. Like you want to go to this database and say, is a student already exists? Do we still need to add the student, or are they already registered in our system? So these three layers of validations basically are the responsibility of your foundation service. It goes and says, before I actually, send the student to be persisted in the system, I want to make sure that the information that is passing through that system, is in a good state before I actually allow it to go and be persisted and be consumed and all that kind of good stuff. The same thing happens to this guy. You're passing in a token, let's say this is your authorization service. You're basically going and saying, the token that's coming through, I want to make sure that it's in correct format before I send it upstream and try to allow this to happen. What that basically means is that I can go up here and say, well, I need an orchestration service to combine these two entities together. Something that goes and says, register student registration orchestration service. And this student registration orchestration service will take your student, try to persist and basically try to generate a token, make sure that the person that's trying to log in actually does exist in the system before you actually proceed with that. And then you put a little controller in front of it. And you go in front of that controller and you basically say, here is my student registrations controller. Just an API endpoint that will basically allow you to go and say, whatever client, ideally will be that your UI, that's coming from the outside world and wants to register a student, I want to be able to kind of enroll that student in my system and also be able to kind of validate the token against the login information that they provided to me. Right. Today, a lot of this stuff, when you're designing systems like these, a lot of this stuff is magic that's happening behind the scene, right? You're basically adding some middleware or, adding some external component that's in your controller. And when that external component is broken, it just kind of sucks in, tens of hours, until you actually kind of figure out what's going on. A simple registration component like this can do the trick. Well, if student can do that, I can also go and design the UI component for this. So that's this part, that's this part. Let's take that part a little bit further here. And I can do exactly the same thing. I need a broker in here that talks to that API. So that will be my student registration API. So let's go up in here. This is your student registration API broker. And then I need a foundation service that makes sure that the data that I'm sending in is just structurally valid. This is a thin client that doesn't do much in there. This will be your service. And then something that converts your view model into a simple model. So that will be a student registration view service. That takes your view model, kind of view, a view model that's coming from the UI and turning it into something usable. And then you need your UI component in here. And this UI component basically has pretty much all the information you need. Think about your text boxes, your drop downs, your date time picker, all of that kind of stuff. So this is student registration component. Now, your UI component may need to use third-party UI components to basically be able to render, pretty UI at the front. This is where you go and add in some base components like a text box base component. You can render in here a drop down, maybe a button base component, all the little a UI components that you might need to be able to kind of construct a form for registration, right? So maybe I'll put in there, maybe label, I don't know, label base, something like that. Label base. So your component in here, this is your presentation layer that's basically feeding, the rendering of the data versus your data layer that's actually feeding that data, kind of pulling that data, pushing that data through the API, right? The last thing you need on top of that is just a simple page. And this page may use one or many components to be able to route, the registration process over to your component. So this is how we designed the whole system. This is basically from a very high level. We basically went and said, I need a UI component, I need an API component, and I need a database, and I need to be able to talk to AAD. Well, all of this now is in place. Now, what does the system look like underneath? And you can imagine like each and every one of those is its own task on an Agile board or an ADE board. So this way you have progress. You can easily see where your team is at or where you're at while you're building the system, and determining which components are done and which components are not done. I can show you guys some real life systems that actually followed exactly this exact same pattern, right? I'll take a break here and just see if anyone has any questions about this part.
So hey Hassan, this is Varun.
Yeah,
So what do you mean when you say the storage broker and API broker? Like, can you give an example?
absolutely.
Like, thank you.
Yeah, absolutely. So what is a broker, right? A broker in its generic definition or generic sense, it's nothing but a thin layer between your core business logic and the outside world. Okay, so let's say this box here is your core logic. This is where all your business rules are, right? And your core logic at some point in time needs to be able to store data in some storage system, right? But I don't want my core logic to be tied up directly to some SQL database or an Oracle database or a Cosmos database. Why? Because technology change all the time. Yesterday we were using Azure Databricks. Today we're talking about Synapse. So it is very possible that you will switch the technology that you're relying on. A good engineering practice is to be able to go and say, I want to be able to have my business logic pluggable into whatever technology that is needed to perform a certain generic task, right? So instead of having your technology, your core business logic talk directly to SQL or Oracle or Cosmos, whatever the case may be, I want to be able to abstract that away and say, well, I don't want to add that kind of hard dependency between my core logic and the outside world. I'm going to add in here an abstraction layer, a very, very thin layer that's sitting in here. And then this thin layer subscribes to a contract that basically allows this core logic to communicate with it. So I'm just going to go here and say my contract is I storage broker, just a simple interface. Let's see, I storage broker. So it's a very thin layer, a contract that says, hey, don't worry about what's underneath. I will take care of the needed implementation to help you communicate with whatever technology you need. Let me show you what this looks like in real life in an open source project. So let's go here real quick and let's go to some open source project. Here's an open source schooling system called OSSS. And this OSSS project is basically communicating. If you go up to the web application here, if you go up to the brokers, and then if you go up to the APIs, you will see that it's communicating with some API. It's going and saying, I'm exposing a contract. Like if you look at the interface for students, for instance, I'm exposing a contract that would allow you eventually to post a student or get all the students. How this is happening underneath, it's way far from the core business logic that's handling it, right? So we basically go at the service layer. If you go in your services layer in here and go into the foundation services and then students, and then you go into this service layer, the service layer is subscribing only to the contract that's called I API broker. When in reality, it's calling that API broker and saying post student async. It doesn't know how this is happening. Is it actually calling an API? Is it calling a database? Is it calling, a file on the system? Doesn't matter, because it's outside of the scope of it. Think about this when you're trying to change the tire on your car, right? There's particular specifications that the tire manufacturers have to have in order for the tire to be usable for your car, right? Your car will function with a tire that's coming from company X or company Y or company Z. That's abstraction because all of them have to conform to that contract. The tire in that particular instance, or the specification rather, is that broker. What do you think, Farhan? Does that make sense?
Yeah, it does. Thank you, Hassan.
Absolutely. So this is what these brokers do, and it could be talking to anything, right? It could be talking to an API. It could be talking to literally any external resource that you have. Think about these brokers as a liaison between your core logic and the outside world. right? It doesn't really care how it's being used. It just knows that it's offering primitive operations where your services internally will do that orchestration and work with, all the logic. Why is that important? It gives you that kind of flexibility to be able to go and say, I don't want to be heavily dependent on SQL or Oracle. I want to be able to run in any system regardless of the technology that I'm using. Okay. Another good example that I want to show you here is that ARM templates, for instance, by a show of hands, how many people here are familiar with ARM templates? Just ballpark. 1, 2, 3, 4, 5, 6. Oh, what, everybody here knows about. Okay, perfect. So ARM templates are very, very specific to Azure, right? But what if one day I want to go and say, well, I want to deploy in Google, or I want to deploy in AWS, or I want to deploy in any other competitor, whoever that competitor is. What does that look like, right? So imagine if I can go and say, well, I want to change my infrastructure from ARM templates to be C# based kind of infrastructure that can go and say, well, here's my services, and here's how I'm going and saying I want to basically create an app service and a database. Check this out. So I can go here and say, hey, create a resource group for me, create an app service for me, create a SQL server, right? Create all of that. And underneath all of this logic, you will find a broker that only knows about Azure. So I can switch that guy at any point in time to whatever technology I want. So here's your web app, it goes and talks to Azure. I can maintain my existing infrastructure code without changing anything in it other than the brokers having them targeting a different cloud provider. So that's the power of these brokers. Instead of rewriting your entire ARM templates, to have them be able to deploy in different environments, maybe you want to deploy on prem, whatever you want to deploy, you're basically abstracting away that in brokers, and you're basically saying, if I change my brokers, I can have my business lifestyle run in any cloud provider out there. Okay, so let's go back to this guy. Okay, so where's this coming from? Like, how is this theory works? Let's go back to this. So this is just me walking you through like one feature end to end. You're starting to build your system from scratch, from raw requirements all the way down. But the one thing that I really want you to focus on is this piece here. You know how our, atom structure and universal kind of galaxies and solar system structure are very similar. So should your software. Your software should be in a place where, it has some consistency from the smallest component, the smallest unit in your service, all the way up to the biggest infrastructure, pieces out there. Just like we went in here and said, let's go down here, let's create a new one here. Just like when I went down here and said your simplest component in the world is to be able to build integration with some database and expose some API, you can take that exact same model and apply that model to, so you have a broker in here, you have something that does the business logic, and then you have an exposure. That guy could be a controller or a UI. But your architecture also can follow the exact same pattern. When you're building an architecture, let me show you a real world example. Let's say you have your microservices architecture. You will notice that in your architecture, there are components that does orchestration. Let's just call this my orchestration microservice. Orchestration microservice. And this orchestration microservice talks to ambassadors or primitive microservices that handle their own data or external communications. Right? So in this particular, system, let's say we have the profiles, something that handles the profiles microservice, and it has its own, let's make this smaller, profile microservice. And you have maybe, courses microservice, and maybe you have teachers microservice. Microservice like this. And each one of those has its own dependency. Like it's basically abstracting away your architecture into its own storage and into its own components. So each one of them could have its own storage, how you want your system to be distributed. And some of them could be just talking to an external API to kind of save that data. You will notice that in your very architecture, there are services that don't necessarily own resources, but make decisions for these resources. So your profiles microservice doesn't really know why these profiles are used for, and it doesn't know what they're needed for or what the thing is. All this microservice knows is that it stores that data in, and it basically allows that data to be retrieved. Where does this data go? It doesn't know. It's zero trust. You know, there's no complete isolation. It has no idea why these things are happening. But in your architecture, you'll also notice that there are components that play the role of a gatekeeper, right? So here's your gatekeeper. And this gatekeeper also doesn't know what's happening behind the scene. All it does know is that it exposes the capability of your services to the outside world, right? The one guy that knows all the little details and all the little secrets about what's going on in your architecture is this orchestration microservice. And you could have multiple ones of them. This is just for the purpose of categorization. So if I mark these dependency or ambassadors with blue like this, and I mark this as purple and mark this as green, you can see the exact same pattern. Like within every service, there is a component that does integration and a component that does, you know, logic and intelligence, and another component that basically does the magic of exposure. And that's how these services are. From the smallest component, like this guy can, this structure here can be exactly what lives inside this one microservice in here, right? But as you zoom out, the exact same thing happens. Now, let me just blow your mind a little bit. Let's take this a little bit further. Imagine this is an entire team of engineers, and they're building this microservices architecture, right? Okay, let me answer this question first. How do I say your name? Is it Levin or Levine? How do I say your name, brother?
Yeah, it's Levin. Thanks for asking.
Levin? Yeah, Levin. Okay. So a gatekeeper, what a gatekeeper is in a microservices architecture, it basically abstracts away the microservices inside your structure, so your clients are not tied up directly or hardly coupled with your internal services. This gives your team the ability to go and say, I want to switch from an orchestration service to 3 orchestration services, and without breaking your contract. So think about this gatekeeper as just an abstraction layer that keeps the outside world away from being tightly coupled to your internal microservices.
So, so the gatekeeper talks to all of the service layer microservices, or just the one?
It talks to whichever ones you want to route to. Like you could have 3 of these in here. Let me show you. It could have 3 of these in here, and it could even talk to one that's primitive, like a primitive microservice. Like it could go directly and talk to this one and says, hey, I want to allow the outside world to add data into your service, like a gateway. Yes. You know,
okay, so whichever ones you want to expose to people consuming the
Yep.
Okay, thank you.
And why is that really cool? Is that because at some point in time, let's say some you know, new pattern or a new trend. Let's just take the hands up first. David Chung, go ahead, David. Go ahead. Like a facade, yes. Yeah.
Yeah. So currently there's only one orchestration microservice. So it knows all the routing to go to either some query, it's going to do profile, hit the profile microservice or the course microservice. But that example you gave, if the gatekeeper is now connected to 3 orchestration microservices, then the logic would have to exist in the gatekeeper as in which one to hit, or how would that work?
No, it shouldn't, because the gatekeeper just kind of translates an external route to an internal route. That's all it does. It doesn't know anything about what's happening behind the scenes. There is also another nice feature to it, and you guys are going to love this. This is one of my favorite pieces. Ideally, if you want to implement a resilient system, you want to throw a queue in here, assuming that you want to implement an eventual consistency pattern. You want to throw a little queue in here. And you're basically going and saying the gatekeeper will return a 201 accepted to your client. Even if your entire infrastructure is down, your client will be none the wiser. They have absolutely no idea that your entire system is down. Why? Because you're queuing up requests, right? So your client, you're basically saying, thank you, your requests have been submitted. We will let you know when we're ready. And you just send them off, right? Even if your entire system is down, you don't have to wake up your engineers in the middle of the night to fix some, you know, Civ 1 issue because 3 moons didn't line up to allow one client to go through the system. Instead, you're taking the request, you're storing it, and you're saying, hey, whenever we're healthy, let's go up and push that. Right. There's also one very powerful thing I think Who mentioned this? This is another thing that the gatekeeper pattern does for you, but let me just read the message real quick. Aditya saying, maybe facade, we can add some validation authorization in the gatekeeper before passing request. Definitely authorization, but I don't know about validation, Aditya. You know, definitely authorization, 100%. But validation, I consider validation to be like business logic. So I keep it to every service to kind of determine what kind of validation they want to run. Unless you mean something else by validation. You mean token validation? Is that what you mean?
Yeah, token validation
Yes,
authorization.
I agree with you 100% then. Yes, we're in
No, by the
agreement.
name, it's Adia, not Aditya.
Yes, Adia. Sorry, Adia. Sounds good. Sorry about that. Okay, feels like adding a queue enables an async pattern. Yes, you can basically, you can even add queues internally within your system, right? And you can easily basically like follow that kind of event sourcing kind of thing. You could even have your system published to an event hub and say, hey, I have a new student, I have a new teacher, I have a new this, and whoever is listening from the other side can basically feed off of these events and be able to kind of build their own infrastructure according to that. It's all abstraction. But the point that I really want you to see here is this part. Any system, no matter how big or small it is, if you break it down into dependency abstraction and logical layer and exposure layers, you can simplify the most complex problems ever, no matter what this problem is. If you can just see it from this tri-nature perspective of everything. Now, let me just kind of blow your minds a little bit. Let me show you something a little bit crazier than that. So this is a big architecture, right? This is your entire system, and this is an entire team, right? In reality, if you look at the biggest enterprise systems in the world, you will notice sometimes people say core services. How many people here have heard this word? Oh, we're core services. We're not customer facing. Anyone heard that word? Yep. Some people heard it. Yep. In a big enterprise system, you will see this. Watch. You will see a bunch of services like these, bunch of architectures and bunch of teams like these, and you'll see also a bunch of teams sitting on the front like this. And these guys are the customer facing, and these guys are the ones doing the orchestrations, and everyone else is basically a dependency. To see how I'm zooming out with you and I'm showing you the big picture, I can mark this entire piece as a dependency facing. That's the Azure folks, the products, the people that give you the app service and give you the queues. And then you have your services. These are the people that doing all the business logic. And maybe this is SharePoint or Dynamics, the people that are sitting in the front serving your system. See how I took this from the smallest kind of component all the way to the biggest systems in the world. Exactly the same pattern, and it keeps growing like that. It keeps evolving. As you zoom out, you start seeing you guys as an individual, you either depend on someone or something, or you do something on your own, or someone else depend on you. This is the theory of the tri-nature of everything. This is just how life works, right? These very computers that you're using right now, they depend on electricity and internet, so that's your brokers. And they do their own function, allowing us to communicate like that. And they also have an exposure layer, which is the keyboards and the mice and all of these things that are going on. What do you think about that? Does that sound like a good deal? Is that clear? Do you see it now? All right. All right. Okay. So, from that path onward, as you are designing a system and as you're building your system like that, there's a little bit deeper stuff that goes into each and every one of these components. Again, tri-nature of everything. Like your components themselves have three types, right? Some components, like your broker components, can be, external consuming brokers. They go and actually feed out of a resource that you don't own as a microservice. And then there's internal consuming brokers, like brokers that basically feed off of your date time. They're reading something from your internal system, what the date time on the server is and all that. And there is near consuming brokers, and these are the ones that consume resources that you actually own. What's an example of that? Let's say you have a service that basically talks to SendGrid. How many people here are familiar with SendGrid? Do you guys know what SendGrid is? It's like a service that sends emails. SendGrid, like Twilio. Okay. So this guy's external, right? Because this is going and feeding off of SendGrid. So you don't own that guy. That's not yours, right? And then there is internal. You're actually just reading out of the existing system that you're in. So you're going and reading just the current date time on the server. So that's date time. Date time. You're just saying what my server time is. And then there is near consuming, which is basically there is a database, and this very microservice is the consumer of this database, right? Again, you will notice that there is a pattern there where why do we need to determine that? Because based on this determination, you're going to determine your risk factor. Where can you roll back and where you can't? If you're an external consuming broker, you can't actually call an external, a resource and go and say, oh, revert, I made a mistake. I sent an email to Satya Nadella by mistake. But if you're here, you can actually revert that. This allows you to determine, what the level of risk is. But let's just move forward into our services. Your services also does something very interesting. Your service is either primitive, just simple operations, add, remove, or they are higher order. They basically do upsert, verify exists, stuff like that, or they are orchestrators. They basically combine multiple entities at the same time. So when you go and say, I want to register a student, and when you register a student, add in a library card for them or register them in the library, your your service architecture would look something like this. You would say, okay, I need a storage broker for a student storage broker, and I need a library card storage broker. So each one of those are responsible for inserting a record for their entity. And then I want a primitive service that basically goes and says, I want something to validate the data before it goes in. That's its own class. I also want to do the same thing with the library card, right? So this is my service. And then I want an orchestration service that goes in and says, hey, register a student and then create a library card for that student. So that would be student registration orchestration service. See how simple you can break your problems like this? And this way, intentionally, of course, how I designed this is that every single one of those is doing one thing and doing it very, very well. And because it's doing it very, very well this way, your code cannot exceed 20, 30 lines of code at any point in time. Because this guy doesn't know anything other than knowing the configuration of the database that it's talking to, and it's offering an API to insert a record. This guy only knows about validating the data and then talking to this storage, whatever it's storing that data. This guy only knows how to delegate. And remember, your class should either do the work or delegate the work, but not both. If your class is delegating and doing work, that means that you kind of lost that single responsibility kind of pattern. So your student registration service is delegator. It just goes and says, hey, add a student, and when that student adds succeed, go ahead and create a library card for them. Right? What stands in front of that? Just a simple exposure layer like an API controller that basically goes and says, here's my student registrations API. Done. How simple is that? Very simple, right? Any questions about any of that? So these guys like primitive higher order orchestrations, and then your exposure layer can either be, you guys probably have, I've already kind of, here's your exposure layer. It's either UI based, it could be a web application, virtual reality, whatever you want it to be. Could be API based, like a protocol based. And then the last thing, it could be like an SDK, a library, all that kind of good stuff. Where's the question here? Observer pattern, iterator. How does design pattern like observer pattern, iterator, decorator, adapter, and factory fit into the high-level construct of exposure orchestrator broker? Right. So let's talk about something like an observer pattern, right? Let's say you have a queue. You're gonna love this a lot. Thank you for asking this question. This is great. Let's say you have a queue in here, and you want to basically observe events that are coming into that queue or event bus. So some client sitting somewhere is sending you, some messages, and you want to be able to react to these messages as they come. The common thing that you will see a lot of people do today is that they go put in an Azure function in front of the queue and call the API. So they add in an additional infrastructure component to kind of do that. But there's a lot smarter way that you can do this. You can basically build something called event broker. right? And this event broker, what's going to happen is that let's say you have an event service in here. And let's say you have an orchestration service up here. And we're basically saying when a student registers, don't actually call the API directly. Just put a message on the queue and tell the student we're going to come back to you later, just like I showed you in the architecture, right? So let's say this is your student registration event orchestration service. Let's say this is your student service, just a very simple service that adds students in the database. And let's say this is your student storage broker, right? And then maybe you have a database sitting in here. This is a pattern that I call the cul-de-sac pattern. It's not a famous pattern. I coined that term, you know, because it just really looks like a cul-de-sac. You go into a street and you go from the other side. So what happens is that the event comes in here, the event broker goes all the way up here, and then it calls this guy, which basically reads the events and persists in a database. In my book, that's observation. You're observing events and you're basically reacting as the events coming. What do you think about that, AJ? Does that work? Yeah. I will provide you some details about the, cul-de-sac pattern, being able to kind of subscribe to a queue and basically react to particular events. It's very, very important, especially if you're building high capacity, high demand systems. This is definitely something you want to take a look at. Okay, back to this guy. So you have UI components, protocols, and basically SDKs. You're basically offering some libraries or, something like that that allows you to communicate. And there's a little bit much deeper stuff into that. We will talk about those in the next session. I planned for about 10 minutes. I finished up a little bit earlier. But
Hey,
in our,
Shan,
go ahead.
Yeah,
Go ahead.
sorry to interrupt you. Can you can I ask you some question about the?
Oh, absolutely. Please go ahead. Go ahead.
Yeah, the last block diagram. Can you go there?
Yep.
The event one. Yeah. So what kind of event we're expecting from the cloud?
So the cloud, let's say this is just a customer, right? So this is just a customer consumer, right? And let me visualize this better. I want you to actually see this. So remember how we said we're going to put a message on the queue. Let me clear out this guy. So remember how we said your customer might put a message on the queue for you and your orchestration service will react to it. Do you remember that part?
Oh, yeah.
Okay, so let's say you have a UI here and the UI went and registered to that gatekeeper and the gatekeeper put a message on the queue. How is this orchestration service going to know about that message that went in that queue?
Oh,
How?
I see.
Right? So it basically goes and says, oh, well, I have a broker that can, listen to my event broker is listening to that queue. And every time a message goes into that queue, it will react to it and basically persist it in the database. Okay. If you pull that trick in your organization, people are going to look at you like you invented fire. I can promise you that right now, because almost 99% of people will put just an Azure function and call an API, at least the ones that I see. All right, cool. All right, any other questions? We draw a lot of pictures. We had a lot of fun. We talked about a lot of things. If you can come out of this conversation with just the understanding of that you need to break your problems this way, and this is how you simulate and create models, you're already on the top. You're already a boss. You're already advanced enough to be able to break any raw requirements. You can sit up with a client and just let them just tell you whatever they want to say, and you're taking notes, and then later on you start circling around the nouns and the verbs, and before you know it, you're creating models and simulations and interactions between these models. Before you know it, you just designed an entire enterprise system just like that. Questions, comments, concerns? Of course, please go and read the standard. It's open, it's on GitHub. You'll find a lot of these details in here, and I'm planning to kind of dive a little bit deeper, maybe give people a little bit of code practice, kind of an assignment at some point in time where people can just, take a look. Since there's a lot of people that signed up to this, like 1,400 people, it's going to be 1 month ahead, but you can always kind of read and watch the YouTube videos and all that kind of stuff. It's very important stuff. Really highly recommend you look into it. Questions?
What are the trade-offs?
The trade-offs.
If you can tell the pros and cons of just approaching this pattern.
Yeah, so the trade-offs here is that sometimes here's the thing. In order for you to write simple software, unlike common belief, Writing simple software actually takes more time. Do we agree on that? So in order for you to actually simplify your software and make it easily maintainable, it's going to take you a little bit more time to actually make that happen. You will see some people, will go and say, hey, I don't need all that nonsense. I'm just going to put all my logic in my controller, and I'm not even going to make it an abstract controller. And I'm just going to call the database, and I'm going to call my AAD directly like that. Obviously, these guys who do that can implement and finish the task in like a day, maybe 2 days. If you follow this pattern, maybe it'll take you a week. But the difference is that this is test-driven, acceptance test, integration test, and it's very maintainable. You won't find one line of code at any point in time that is out of, focus. You will never end up writing nested if statements or nested for loops if you follow that particular pattern. It's heavily focused on the readability of your software and the maintainability of your software. You know what I mean? If you don't do that, so here's the thing, you can write an entire system in one file, one line, one page, but for the people that will come after that and try to maintain your system, it'll be a nightmare for them. Right? Let's take a stroll. Let's look at one complex system that I'm building in the open source space, just to show you. Here's a very complex system that basically goes and reads information and tries to process that information. Just take a look here. Here's digestion. Let's take a look at this project here. This project here went all the way up to a level that I call coordination services, right? This guy is doing a lot of work, even though it looks like the entire file is 100 lines of code. It's doing a lot of work, but it's 100 lines of code. In fact, actually, the one part that it's actually doing the work is just this guy. This is back to the event. It's listening to events and then going and saying process and effort contribution. And this process effort contribution is just calling its dependencies. And that's it. It's delegating the work. It's getting the message and it's processing the message. That's it. See what I'm saying? It makes it even a lot simpler and easier for you to break down your tasks in a way where your engineers will be able to kind of consume and deliver PRs on a daily basis. I joined a team of engineers where they roll up a PR or a feature every 2 features per quarters, and following that engineering standard, they delivered 35 plus features. 35 plus features, not just endpoints, features, end-to-end, from the UI to the back end.
I'm just wondering, like, how can we apply this principle on data processing? Like, if it's big data processing, how can you apply it? So is it possible to apply this?
Give me a requirement and I'll turn it for you in a second into an application. Just give me a requirement, any requirement that you have.
Okay, let's say we have.
Be careful. You're a Microsoft employee. Don't share stuff.
Oh,
okay?
yeah.
This is going on YouTube, so be careful. Go ahead.
Yeah. I'm just telling, like, okay,
Good.
let's say we have Azure subscription data. We are trying to calculate like what subscription uses, how much money, what's the consumption per subscription.
What? Okay, so let me just write your requirement. I'm gonna play a PM, and then I'm gonna play an architect, and I'm gonna play a developer all in one settings. What do you think about that? Do you think I could do that? Let's do that. So let's go here and say, I want to be able to know what is the cost per subscription in Azure per month. Yes? Is that what it is?
Yep.
Now look how my brain translates this, right? You're basically telling me that there are subscriptions. So I want to go and build a subscription API broker. So I can go read the subscriptions from Azure. Is that right? And I also want to go and say, I want to know the subscription expense API broker, right? What every subscription is consuming, right? And now I want 2 services ahead of this in here. And I want a simple service that goes here and says this expenses API broker needs a processing service that will go and tell me, hey, give me the expense within a particular period of time. So here's your subscription service. And here's your subscription processing service. I'll even simplify it for you. because I actually want to sell you on this here. Subscription service. I totally messed up that expense part, did I? Expense, right? And then I want an orchestration to sit down in here and basically goes and says, give me the subscription, let me go get the information for that subscription, then let me go get the expense for that subscription. Now let's say this information is not easily retrievable. Easy. Let me go in here and add subscription expense details service and subscription expense details storage broker. And I'm storing these details into my own database so I don't have to run through that processing, call these APIs every time. Boom, here's your subscription orchestration service, expense orchestration service. And here's a simple API that all it takes is just a simple subscription ID and goes and pulls that subscription detail and basically finds out whether I have that expense already so I can pull it from the database, or I need to go call Azure and get that details from Azure and persist that detail to cache it later if someone needs that detail. Does that solve the problem? What do you think?
Yep, this is solves the problem for the view of the part, but still that processing part is not resolved yet, right?
So when you say processing, you mean pulling all the expenses and breaking them down per month, right?
Yes, but
That's the
also what I'm thinking is, okay, Azure subscription, we don't know how many subscriptions are there, but it's many. And then their consumptions are very huge. So basically, if we just think about in a big data processing world, so the computation is very heavy,
right.
So how can we apply this on the computation side?
Right. So okay, your output is for you to be able to see the cost per subscription per month. Yes?
Yep.
Okay. This is an offline process. You know what that means? It means that I don't want someone sitting on the other side waiting for me to do that computation. I want that computation to be done and ready and stored for me so I can just pull it out, and visualize it on a Power BI or whatever the case may be. You may have run into situations where Power BI is the slowest in the world. Do you know why they're slow? Because they're doing the computation in real time instead of just storing that information, like taking a snapshot, right? So what I'm thinking, is that I would put like a cron job that hits my controller and it goes and pulls that information every 30 days. And then the controller itself is exposing an API endpoint that goes and says, hey, follow that pipeline so I can just pull the information I'm reading. So your writing path will go like this. This is your writing path. It will cover all this area. You're going and basically pulling information from here and storing that data in here. And your reading path is just this guy. Let me show you something in the real world that I've done that's similar to this. So if you're following the standard, I can easily look at your open source code and tell you in real time, see how I pulled all that data in a second? That's hundreds and hundreds of thousands of data points. Why is that? Because I already processed that data. This system here, do you know what it does? It basically goes and says, I'm looking at your code and it seems like you're leaning more back end than full stack or front end. Right? It goes in here and generates a resume for me out of my open source code. I didn't write any of that. How does it do that so fast? Because it's already processing back in the back end. I already saved a copy of it. So every time a new pull request gets merged in open source space, it immediately goes and generates a new record and calculates. It even will go and tell me so fast to the point where it says, hey, Hassan, normally in order for you to implement Broker, you take about 15 hours to deliver it. On the infrastructure, you take about 30 minutes. That's your average based on all the pull requests that you opened. So if you follow the standard, I can easily tell you where your strengths are and your weaknesses are. I can even give you a chart and tell you what kind of engineer you are and where you need to invest in to grow your skill sets. Because everything is broken into pieces, right? Easily modifiable and configurable, right? I don't know if that answers your questions.
Yeah, this is amazing. So I never
let me tell you something crazier than that. If I go to this leaderboard, I'm pulling the data for hundreds of engineers that follow the engineering standard. in a second, and each one of them has tons and tons of data points in a second. How did that happen? Because it's pre-calculated, pre-processed data. Exactly that. I swear to God, man, this is exactly how it's happening behind the scene. It just hits up in every hour and basically goes and updates that report. And just for a user experience perspective, you go and say, hey, by the way, the last time this report was updated was 1/1/2020, 5 o'clock or something like that. And then if you want to check again later, please check in an hour or something like that. But there's more than this, right? We're almost at the hour. We're exactly at the hour, 1 minute over. That's great. You know, I'm glad that you guys have questions, but there's more to this than that. There's so much stuff I want to share with you in terms of how you design, even if you don't know user experience at all and you never wrote UI, I can help you kind of see how you design a system that is fluent, intuitive, and easy to use, even if you've never written one line of code in building UI system. That would be the next session in a month from now. I appreciate you all coming in today. I really appreciate it, and I hope this was useful to you somehow. You know, I know people kind of start to get bored and just trickling out, but yeah, feel free to reach out at any point in time if you have any comments or questions. You know, I'm more than happy to set up very specific sessions, just one-on-one. You can tell me about the specific issue that you're dealing with. I can make engineering fun for you. You look forward to it. You feel excited that you want to go and build software every day. All right, guys, thank you so much. I appreciate you and have a wonderful day. Take care. Bye.
Yes, and this was great. Thank you.
Thank you, guys. Take care. Bye.